Pre-stressing force P will be equal to cross-section area, that is 320, into initial stress 1000. So that will be equal to 320 kilonewtons. Cross-section area of concrete is 200 mm wide and 300 mm deep, that is 6 into 10 power 4 mm square. Modular ratio alpha is ES by AC, that is 210 by 35, which is equal to 6. And I, moment of inertia, is BD cube by 12. B is 200 into D is 300 cube by 12, which is equal to 45 into 10 power 7 mm to the power of 4. Stress in concrete at the level of steel will be equal to P by A plus PE by I into Y. Eccentricity is given as 50 mm. So then P is 320 into 10 power 3 in Newton by area is 6 into 10 power 4 plus P is 320 into 10 power 3 into eccentricity is 50 by I is 45 into 10 power 7 into Y is 50. So that will be equal to 7 Newton per mm square. Then tabulating type of losses for pre-tensioning and post-tensioning. For post-tensioning, there is no elastic deformation loss if cables are simultaneously tensioned. Then in pre-tensioning, it is given as alpha into Fc. So that is equal to alpha is 6 into Fc is obtained as 7. So that will be 42 Newton per mm square. Relaxation of stress in steel can be taken as 5% of initial stress. So 5% of 1000, that will be equal to 50 Newton per mm square. Same here also, 5% of 1000, so 5 by 100 times of 1000 will be equal to 50 Newton per mm square. Due to creep of concrete, it is 5 into Fc into alpha, that will be equal to 5 is 1.6 into Fc is 7 into alpha is 6, so that is equal to 67.2. Here also the same, 5 into Fc into alpha, that is 67.2 Newton per mm square. Due to shrinkage of concrete, it is shrinkage coefficient into Es, that is 300 into 10 power minus 6 into Young's modulus of steel is 210 Newton per kilonewton per mm square. So convert into Newton per mm square into 10 power 3. So that will be equal to 63 Newton per mm square. Whereas here epsilon Cs is given as 200 into 10 power minus 6 into Young's modulus of steel is 210 into 10 power 3 to convert into Newton per mm square. So this will be equal to 21 Newton per mm square. Due to anchorage slip, there is no loss in pre-tensioning, whereas in post-tensioning, it will be equal to PL by AA, or that can be written as Young's modulus of steel by L into delta L, that is equal to delta L is given as 1 mm. Young's modulus of steel is 210 into 10 power 3 by L is given as 10 meters. So 10 into 10 power 3, which will be equal to 21 Newton per mm square. Due to friction, there is no loss in pre-tension beam, whereas in post-tensioning, it will be equal to P naught, that is initial stress, into mu alpha plus Kx. Mu is given as 0, so this term will become 0. Then initial stress is 1000 into K is given as 0.0015 per meter length into X is L meters, so that is 10, which will be equal to 15 Newton per mm square. The total loss here is 222.2 Newton per mm square, and here it is 195.2 Newton per mm square. The percentage loss will be loss by initial, that is 1000 into 100 in percentage, which is 22.22%. Then here it will be 19.52%.